In today's video, we're going to explore something mind-blowing: the sheer scale of our galaxy, the Milky Way. Get ready, because the numbers we're about to talk about will make your head spin. Let's start with the basics. Our galaxy, the Milky Way, contains at least 200 billion stars. And that's not all. It also has massive clouds of gas and dust. Imagine a huge rotating disk floating in the vast emptiness of space with a diameter of about 160,000 light-years. Now, 160,000 light-years might sound like an abstract number to most people. It's so big that it's hard to wrap our heads around. But don't worry, we're going to break it down for you in a way that you'll really feel it. Let's start with Earth, our home. The Earth's diameter is about 12,702 kilometers, and the closest object to us is the Moon, sitting at a distance of about 380,000 kilometers. That's pretty big, right? Now, within our solar system, there are 8 planets, and the farthest one, Neptune, is about 4.5 billion kilometers from the Sun. Light takes about 4.3 hours to travel that distance. But Neptune isn't the edge of the solar system. Beyond Neptune, we have the Kuiper Belt and the Oort cloud. The Oort cloud is considered the boundary of the solar system, a giant spherical cloud that wraps around the whole system. From the Sun to the edge of the Oort cloud is about 1 light-year away. So, what is a light-year? A light-year is the distance light travels in 1 year, moving at a speed of about 300,000 kilometers per second. Let's look at the Voyager 1 spacecraft, which holds the record for the farthest man-made object from Earth. It travels at about 17 kilometers per second, and it has already crossed the escape velocity of the solar system. But even at this speed, it will take thousands of years to leave the solar system. Just imagine how vast the solar system is. Now, when it comes to the Milky Way, its diameter is an astonishing 160,000 light-years. If Voyager 1 were to travel from one side of the galaxy to the other, it would take about 500 million years. Even if we were traveling at the speed of light, it would still take 160,000 years to cross the Milky Way. And considering human lifespans are only around 100 years, that's just a tiny fraction of time in comparison. To really grasp how huge this is, let's shrink the Milky Way down to the size of Earth. The Milky Way's diameter is about 160,000 light-years, and 1 light-year is roughly 9.46 trillion kilometers. That means the galaxy's diameter is about 1,500 quadrillion kilometers. Now, let's shrink that to the size of Earth, with a diameter of 12,702 kilometers. If we do the math, the Earth's size is shrunk to about 107.3 nanometers. That's the size of a virus or a large molecule, way smaller than a bacterium. If we do this for the Sun, whose actual diameter is about 1.39 million kilometers, we'll find it shrinks to about 11.71 micrometers, the size of a red blood cell or a tiny dust particle. And if we shrink the entire solar system, which spans about 2 light-years, it would be reduced to just 59 meters, roughly the size of a football field. So even if we shrink the Milky Way to the size of Earth, the solar system would still only be the size of a football field, and Earth and the Sun would be almost invisible, like specks of dust. In the grand scale of the galaxy, we are smaller than the tiniest particles. But here's where it gets even crazier. There's a galaxy speeding towards us, the Andromeda Galaxy. It's moving so fast that in about 4 billion years, it will collide with the Milky Way, merging into a giant new galaxy. Edwin Hubble discovered that most galaxies are moving away from us, proving the universe is expanding. But Andromeda is doing the opposite. It's moving towards us at incredible speed. How is that possible? Let's dive into why this is happening. Andromeda is a spiral galaxy, much like the Milky Way, but it's about 220,000 light-years across and contains at least 1 trillion stars, much bigger than the Milky Way. So why is it speeding towards us? Well, it all comes down to gravity. The expansion of the universe is causing galaxies to move away from each other, but the gravity between Andromeda and the Milky Way is stronger than the universe's expansion, causing Andromeda to head towards us at about 120 per second. In about 4 billion years, the two galaxies will begin to collide, but don't worry, because stars are far apart, so they won't actually collide. Instead, their gravitational pull will warp their shapes, triggering massive star formation and a huge burst of light. Over the next 2 to 3 billion years, they'll slowly merge, eventually forming a giant elliptical galaxy. Now, think about this. When you look up at the night sky, the stars you see are not what they look like right now. You're looking at the past. That's right. You're seeing light that took years, centuries, or even billions of years to reach Earth. Light from the moon takes just 1.3 seconds to get here, so we see it as it was 1.3 seconds ago. But when we look at the sun, which is 150 million kilometers away, it takes about 8 minutes for the light to travel that distance. So, when you see the sun rise, you're actually seeing it 8 minutes ago. Now, if you look at the stars in the sky, the time delay gets even more significant. Take Sirius, the brightest star in the night sky, which is about 8.6 light years away. That means when you see it, you're looking at it 8.6 years ago, and if it exploded today, we wouldn't see it until 2034. Let's take the Pillars of Creation, about 6,500 light years away. Some of the massive stars there are about to go supernova. So, the Pillars of Creation we see now might have already been destroyed, but because of the speed of light, we won't know until 6,500 years from now. In fact, if you were standing inside the Pillars of Creation right now and looking back at Earth, you would see Earth as it was 6,500 years ago, during the late Stone Age. So, when we look at the universe through telescopes, we're actually seeing snapshots of the past. The further we look, the further back in time we're seeing. We've never seen the real-time universe. What we see is just a projection of history. But don't be fooled. These aren't just illusions. They are real, and they're the only window we have into understanding the universe's evolution, from the Big Bang to the formation of galaxies and the emergence of life.